What if the universe is not infinite? What if, somewhere beyond the furthest galaxy we can see, there is an edge? For decades, we've been told that the universe has no center and no boundary. It simply expands in all directions. No walls, no limits, just endless space. But what if that assumption is wrong? Modern cosmology is built on something called the cosmological principle. The idea that, on large scales, the universe looks the same everywhere. No special locations, no preferred directions. It's elegant, it's simple, and it might not be perfectly true. When astronomers map the large-scale structure of the cosmos, they see something astonishing. Galaxies are not evenly distributed. They form a vast cosmic web, filaments, clusters, and enormous empty voids stretching hundreds of millions of light years. This structure already tells us something important. The universe is not smooth. Now imagine zooming out even further. Beyond what we can observe lies something called the cosmic horizon. This isn't a physical wall. It's the limit of how far light has had time to travel since the Big Bang. We cannot see beyond it because light from those regions hasn't reached us yet. But just because we cannot see beyond the horizon doesn't mean nothing is there. Some cosmologists have proposed that our observable universe could be just a patch inside something much larger, a region within a greater structure, perhaps even one with a boundary. Inflation theory suggests that shortly after the Big Bang, space expanded exponentially fast. But inflation may not have ended everywhere at once. Some regions could have stopped inflating, forming bubble universes, while others continued expanding. In that scenario, our universe might be one bubble among many, and bubbles have edges. If our bubble universe collided with another in the distant past, it could leave subtle imprints in the cosmic microwave background, the faint radiation left over from the Big Bang. Scientists have searched for these scars. So far, nothing definitive. But anomalies exist. Cold spots, slight asymmetries, tiny irregularities that spark debate. Now here's the unsettling question. If there is a boundary, not necessarily a wall, but a transition zone, what happens near it? Physics as we know it is based on symmetries, uniformity, continuity. But near a boundary, conditions change. Constants may shift. Geometry could distort. Even time might behave differently. And here's where it becomes even stranger. Some theoretical models suggest that space itself might be curved in higher dimensions. Imagine the surface of a sphere. To a two-dimensional being living on that surface, space would appear infinite. They could travel forever without encountering an edge. But in reality, the surface is finite. Now apply that idea to our three-dimensional universe. It could be finite, yet without a conventional edge. But what if the geometry isn't perfectly smooth? What if, at extreme scales, there are limits, topological defects, boundaries in higher dimensional space? String theory and brain cosmology propose that our universe could exist on a membrane floating in a higher dimensional space. If that's true, there could be neighboring branes, other universes, separated by microscopic gaps in extra dimensions. If those membranes shift, they could interact. Gravity might leak, or space itself could warp near these boundaries. We may never physically reach such a limit. The universe is expanding faster than we can travel. Regions beyond a certain distance are already receding from us faster than light due to expansion. But that expansion creates another unsettling idea. As time passes, more and more galaxies cross our cosmic horizon. They disappear permanently from view, not because they are destroyed, but because space between us stretches too fast. In a sense, the observable universe is shrinking. Billions of years from now, future civilizations may look up and see only their own galaxy. No evidence of expansion, no cosmic background radiation, no large-scale structure. They would conclude they live in an isolated universe. But they would be wrong. We are lucky, or perhaps just early, to exist at a time when we can still see the larger picture. Which brings us back to the boundary question. If our observable patch is temporary, if horizons shift, if geometry bends, how confident can we be that the universe has no limits? Physics does not forbid a finite cosmos. It does not forbid higher dimensional embedding. It does not forbid topological boundaries beyond observation. What it does forbid is certainty without evidence. Right now, the best data suggests the universe is flat to high precision. But flat does not mean infinite. It only describes curvature locally. Just like standing on Earth feels flat until you zoom out. The true shape of the cosmos could be far more complex than we imagine. And here's the deeper thought. If the universe has a boundary, then it has structure beyond what we can observe. If it has structure, it may have constraints. If it has constraints, it may have rules defined by something larger. Not necessarily a creator, but a framework, a meta-geometry. We may be living inside a region of a greater reality, unable to perceive its limits, yet fundamentally shaped by them. Every law of physics we measure, every constant we calculate, every symmetry we rely on, all could be local, temporary, context-dependent. So the next time you look at the night sky, consider this. The darkness beyond the stars may not stretch forever. There may be a limit, not a wall, not a cliff, but a transition. And somewhere beyond it, something else entirely.